So in this demo, we're going to look at a command that's going to generate a number of random spheres based on one user argument. Just to show in action, I've already loaded the plugin here. So we've got custom create sphere, say 10, and run that. You can see it's generated 10 random spheres. I can also undo it. So say 200. Run it again. You can see now it's generated 200 random spheres. So the overall process of this is I'm going to basically execute a few commands and then generate these spheres, and I'm going to name them and do a few other bits and pieces. I'm also going to write this as a full Maya command as opposed to just using the simple command. So what we do is we inherit from mproxy command, and then I'm going to implement the following methods. So we've got the doIt method, we've got the RedoIt and the undoIt method. As you will notice in here, if I go edit, undo, do delete, edit, undo, select, you can see that we've got this whole sort of process of do stuff. And what we've also got is repeat, custom create sphere. So we can repeat it, and then we can undo, then we can redo, then we can undo. So there's a whole stack of do, redo, undo, and so on in Maya. So part of that is by implementing the RedoIt, undoIt, and setting this flag is undoable. You'll also notice there's this thing called a creator. This is like a factory method that when we load the plugin, that factory method is used to create the command once. Then when we call the command, the doIt, RedoIt, and undoIt methods are called. So there's a few bits and pieces in here. I'll go through and sort of explain the code as I go through, because it's most probably easier seeing it from the point of view of code. So let's start with the header here. So at the moment, there's very little in the way of anything stored in this class. We've got custom sphere, extends npx command. I've got a default destructor, so it's virtual because of the inheritance, so we need a virtual destructor. I've just assigned that to default. I'm not doing anything particularly in here. Then we've got the doIt command. Now, from the documentation, so I put it in the header file just because it makes it easier to explain what's going on. So the doIt method should collect whatever information is required to do the task and store it in a local class data. It should finally call RedoIt to make the command happen. The RedoIt method should do the actual work using only the local class data. The undoIt method should undo the actual work, again using only the local class data. So this is quite an important thing, that this class, once we're doing the undo, redo, we have to store what we're doing. And in particular, in this case, we're only storing the number that we created when we did it. But if we're writing more complex code, we need to remember this sort of stuff, because if we want to hook into undo and redo, we have to remember that data by calling these commands. You'll also notice I'm using C++11 inheritance features. Because we're on the VFX reference platform, we can use all the features. I'm running Maya 2014, which I believe is working towards the VFX reference platform for 23, which means we're using C++17 as our core standard. Might be wrong on that. But anyway, override. This is marking, because we're using inheritance here, that this method overrides a method in the base class. Really useful to use override when you can, so that it makes sure that that's happening. So doIt, passed in an arguments list, RedoIt, undoIt, is undoable. This is a flag just to say whether or not this is part of the undo chain. And we set it to true so that we know it can be undone. Creator, as you can see, returns a static void. It's a pointer. This is used by the plugin function set to basically construct this command, and we'll look at that later. And here's the local data that I'm storing. In this case, mcount is basically just the the count of how many objects we're going to create. Let's go to the C++ here. So a few bits and pieces here. So the first thing, I'm just going to go back to my slides to show a few things. Remove that mode. So I've got a few utility macros here. Now, most of the Maya API uses this, which is, so if you look at the demos, it's a standard C macro that basically just goes through, passes in the status and the message, checks to see if the status is there, prints out an error string if there's an error, and returns k failure. This is, I mentioned in the first part of this lecture, we should not let errors fall silently. We should always return proper error messages because that feeds into the bigger plugin ecosystem and it can handle things correctly. Now, macros are fine. These will get expanded inline in your code and it makes your code a lot easier. We can also create a templated version. Okay, this is a function call now, so it's templated. Most probably get inlined anyway, the way the code works. So I've got a template version. You get slightly better error checking and things like that. Makes compilation easier sometimes. Your mileage may vary. I mean, this is more of a stylistic thing. So I'm using that at the moment in these demos, and we can sort of look at the different versions as and when we go. So template, check status and return if failed. Basically, that's going to just bomb out of any program and return either success or failure, depending on what we're doing. For this demo, I'm using the C++ 11 and beyond random number generator. Your mileage may vary with this. It's not the fastest of generators, but it's fine. Maya does have mrandom, but mrandom is an odd thing. If you're used to using random in Mel, you'll know what it is, but it's about generating iterations through sequences of random numbers, and it didn't quite do what I wanted to do in this case, so I decided to use the standard C++ random. You could use studrand as well, which would most probably be quicker, but obviously you don't get as good a distribution and things like that. So I've made this global in this module, so I've instantiated one of these. It would be good to add different seeds and things like that into it, which we may do as the exercise later. So next, here's the doIt command. So I mentioned earlier on that everything's being done in respect to the RedoIt command. So the job of the doIt command is to grab the command line arguments. In this case, it's going to be a single argument, which is going to be the number of spheres to create. So I'm doing some error checking here. So the first thing is marglist is a class. It's got a series of different methods. So the first one is I'm checking to make sure that I've got one argument. If I don't, then I'm displaying command requires one argument as an error, and I'm returning the failure. Again, we can see this in action if I go back to Maya and I just say here the custom create sphere and press enter. It's giving me requires one argument there. The other thing I'm checking is to make sure that I don't pass in negative values. So again, if we go back to the code here, you can see that I'm checking the argument's length is 1. I'm then converting this into an integer. So again, argument list comes in. It's effectively an array object of m strings, so Maya strings. And what we're going to do is we are going to say convert argument 0 as an integer. So in this case, it's a very, very simple parsing, only one value, no -n or anything like that. So we're not using named arguments or anything. I'm just saying, give me one argument and try and convert it to an integer. And so if that can't be converted to an integer, again, notice here I've got an m status. I'm grabbing that m status. That's being passed by reference into the conversion function. And what it will do is it will set the status to a failure if it doesn't work. So I'm checking that and then saying argument is not an integer, returning failure. Otherwise, it's obviously can be converted into an integer. Now I'm just checking to make sure it's greater than or equal to 0 and going through. And once that's done, obviously this has been stored as mcount in our class, so it's stored. I'm returning a call to RedoIt. And RedoIt's going to do all the hard work in the processing here. So here's RedoIt. So I mentioned in the previous lecture the fun and games we can have with mstring. So mstring doesn't have the standard style format specifiers or anything that you would come to expect from a modern string library. What it has instead is the ability to create strings by using the format command. And it has up to 10 of these caret index and then s for string values, which the format command can then go in and replace. Now I'm using mstring as an example of how to do this and how to use mstring. Typically when I'm writing my own code, I would use the FMT library because it's just so much simpler, much more modern C++. You can also use smprintf as well, which will do a similar thing and make life easier. But again, this is about learning about Maya strings. So in this case, I've got a string called create. This is basically, what I'm going to do is I'm going to create a Maya command, and it's going to sort of be something like this, that I'm going to create the command, which is going to go sphere minus n for name, sphere 1, minus radius 0.2, like that, and that should create my sphere, as you can see there. Then I'm going to create another command, which is going to say move 2, 2, 2, that thing, to move it. So these are the two commands. So basically what I'm doing is I'm going to build these commands up, and then I'm going to evaluate those commands to run them, as you would do in Mel code and other things like that. So if we go back again and have a look. So here are my two strings. These are the commands that I'm building up, the Maya commands. Notice I'm having to escape quotes because that needs to be in a quote for the name. And I've got these elements in here. That's not needed anymore. That was when I was experimenting with other stuff. So what I've got here now is a series of M strings that I'm going to build up and set up to go into replace these string values here. And again, this is where the argument lists and things like that do become fun, and my string is harder to use than using sprintf or FMT. So what I'm doing here, two distributions. So the radius of my sphere is from 0.8 to 4.5, and the position minus 20 to 20. This is from C++ random, just gives us those distributions. So it's giving us a real, uniform real distribution. Now I'm looping from 0 to the number of spheres that we stored previously. And then I'm saying, so radius is a string. So as you can see here, this is why I hate n string. I'm going to first create a Maya command as follows: sphere minus name sphere n, where n is this. So first, radius is a string. What I want to do is I want to set that string from a floating point value. So we have to call set. Same for index. I'm setting that with the current I value. If you think about it, normally with format specifiers, it would be %f, %d. And then what I'm calling is command dot format. So command is an empty string object, and now I'm formatting this to say, here's the string, replace index as number 1, replace radius as number 2. So what I've done now is basically created a new string based on this format specifier to put this in. Now we can simplify this a little bit, and I will show you some other examples of this in later examples, but at its simplest level, this is what we're doing. Then next, we are running execute commands. So from mglobal, we can build up a mel command and execute that basically in the main Maya thread from within the plugin. So this is going to execute this mel command that we've just created. and it's going to return an M status here. That could actually be an auto now as well in modern C++, but I've got M status there. And I'm checking to make sure that that was correct, that it worked. Now I'm setting my X, my Y, and my Z values and going through setting the position values for that string. And again, another format of the move command now. So I'm building up move, X, Y, and Z values, and the name of the sphere. And again, we have to use the format specifier to replace the things in that string. And then I'm executing that command. As the sphere object is still selected because we've executed the command, when we execute a command, that object is still selected in Maya. We just need to call move and it will do it on that one. And again, we just check to make sure that was correct. Finally go through and I'm just printing some messages out, so how many spheres I created, and I return case success. Undo it will be called, if we call undo, all I'm doing here is looping through and deleting the sphere at that index because I've got the name sphere there. It will just do it. We've got is undoable, which will return as true, so we know that we've got do and undo. And this is the creator method, and the creator basically is a factory. It's going to return a new instance of the custom sphere object, so it creates itself. So it's a very, very simple approach to a factory method. Right, the only other thing in here now is the core plugin code. So plugins are generated as a function set from Maya from the M function plugin, and there are different types of plugins that we can create and register. So basically, when we create this initialize plugin function, we create a function set for a plugin, and that's based on the object that's passed in here. So when we click on and off on the load plugin feature, this gets called, passing in the object of the one it wants to load. We apply the function set to it, and then this is the name of, so you can see we're saying plugin register command. If we're creating a node, it will be register node. If we're creating other things, it will be other things in here. There's a series of different methods in this header. This is the name that we give the command. So in this case, custom create sphere. And this is the factory method or the creator method that will instantiate that object. Again, check the status. If we can't register it, then we return the errors. Otherwise, it returns true. Uninitialized plugin, same thing as the bigger thing. So we deregister the command, same name here as here. Again, a lot of the time you'd have that as a constant in your code or something like that. And it just checks it. So this is the core loading, unloading code that registers everything for us. Final thing with the CMake lists. So again, very similar as before, but now obviously I've got two CPP files. I've got the one for the elements there and that plugin code. Last time this was written for us, and I've included my header there. Everything else is exactly the same. And as you can see, when we go back to Maya now, this all works quite nicely. So custom create sphere 200. It's created 200 spheres for us there, and it's sort of working. And then if we undo, do an undo, and it's gone. So that's doing it from that one. Custom create sphere 10. So I'm going to create 10 spheres. Oops, spelled that wrong. Run that. Now, what you will notice is if we undo and then redo, and then undo and redo and undo and redo, it changes each time. And obviously this is because of the nature of the random that we're using to do everything. So It could be that we store all the positions or do something else. That obviously takes up a lot of data. You don't want to do that. I mean, this is just an example. It's not necessarily something that we would, write in production code, but it does show how commands can be created and what we can do. So there is an exercise along with this. Go through all the different elements here that I've explained already, and you can look through this yourself. So I have got an exercise here. I will go through and record a video of this and put it up in the code as well, because I have a solution to this. And we're going to have a look at marglist and how we can use the marglist parser to do this as well. So I will set this as an exercise. Don't know why that's gone across there. So I will record that video soon. In the next video, we're going to have a look at Python plugins as well, because they're very similar as well.